to go.
All right. So good morning and welcome back to HESCO's Smart Safety webinar. This is part 303. This is where we'll wrap it all up and bring everything together. I do want to thank you all who have been here for the 3 days. And if you made it, you'll be receiving in the mail a gold star for your perfect attendance. Actually, no, really, if you did make it, it makes Jim and I really feel awesome that you've been here for the entire seminar. We'd like to think that it's an indication of all the hard work we put into this webinar has paid off, that we're presenting information to you that's interesting, informative, and helpful. So thank you on that end of it. Just in case there's someone joining us for the first time today, my name's Andy Restalis. I'm the HESCO Industrial Control, Safety, and Sensor Product Manager. And joining me today is Jim Drew. Jim is the Rockwell Safety Sensor Industrial Control Lead. He's responsible for covering all of New England and part of New York. And I think you all know what's coming next, the disclaimer. We want to make sure that everyone is aware that everything that we cover in this webinar may and may not fully be representative of all the details that you'll need to create a safe design. We want to urge everyone out there to do your homework in looking up and reading the current standards, looking into what makes sense for you. But of course, we're here to assist you if you should need any help in that process. All right. Today's agenda, we're going to be talking about machine safety, product solutions, and some application tools, then tie everything together that we have been talking about for the last 3 days. So hopefully at the end of today, it all wraps together and makes sense to you as one big mash unit. All right, go ahead and so we'll run through this again. What does safety mean? It's a process. We learned about the safety life cycle and the different steps that we need to follow to design a safety solution. That our solutions are driven directly by the risk, that these solutions are tied to the current safety standards. Information enabled, machines that will alert us when maintenance is due or that a sensor is about to fail. Data collection, there's a lot of valuable information that can be collected from our plant floors that can help us with our productivity. And with higher productivity, obviously, is higher profits. We also have integration or integrity. Manufacturing is moving towards more automation. We're starting to use smarter machines. With smarter machines, we need smarter safety. Along with this, we now have more robots and cobots out on the floor working side by side with our employees that we need to protect. Technology, making good use of all the great tools, and there are a lot of them out there that we have at our access. And this is what makes up smart safety. Go ahead. To recap what we've covered so far. Day one, we covered modern safety thinking and philosophies. We talked about the whole passive versus active, looking at the seatbelt versus the airbag type philosophies for safety. We looked at the whole transformation of safety, safety being an integral part of the design process now, rather than an afterthought. We covered safety productivity, where doing safety in a modern, smart approach provides us with the opportunity to be safe and productive at the same time. And we have talked a lot about the safety life cycle. It has been a part of our discussion in day 1 and 2. We'll continue to talk a little bit about it today. In the first day, we discussed the first 2 key steps of the cycle, the risk assessment and the safety specification, the FSRS, Functional Safety Requirement Specification. On the second day, we moved into functional safety standards and tied that through the life cycle with the design and verification, along with the installation and validation. Then we moved into safety tools. We talked about some of the tools that are available and did a quick summary on each of them. We will mention a few of those tools again today when we start to tie our design together with actual products. We've covered a lot of ground in the last 2 days and have learned a lot of really key elements that we'll need to remember. All right, let's move on to today's discussion. So how do we make this all make sense? How do we take these requirements that we have come up with based on our risk assessment and what we have written into our FSRS? How do we choose the right method, products, solutions to make it easy for ourselves to get to where we want to go? And make sure that we are going to have a system that is going to be reliable over time to the expectations that we had. We're going to title this Smart Contemporary Solutions to Simplify Applying Implements. How do you make it easier to get there? And with that, I will turn it over to Jim.
Super. Thanks, Andy. Just as Andy was describing, getting to where we need to go, there are many ways to get there. Just like anything else in life, if we want to go to Pennsylvania, we can drive directly to Pennsylvania, or we can get to Pennsylvania through California. It might be a little more desirable if you just want to get to Pennsylvania to just drive to Pennsylvania. So making sure that we get there the simplest way possible and the most expedient way possible is going to be part of the thought process, right? And when we look at smart safety in particular, we call it smart safety, or we also call it contemporary safety a lot in a bunch of these slides, where we talk about, safety is literally the ante that we need no matter what, even if we choose not to have what we would call a smarter contemporary solution. Safety has to be done, right? And we need to follow that process. We need to drive through that risk assessment, through the functional safety requirement specification. We need to then design and verify. We need to validate when we install, maintain, and improve, no matter what we do. But really where the intelligence comes into play is getting beyond just that level of safety only. We really need to get our minds around ensuring that our processes and our selections in product and the way that we implement these safety systems is truly focused on a bigger picture than just safety. We want to be safety plus, right? We want to be safety in such a way that first of all, we want to make sure we don't impede any operations, if at all possible, that operators or other folks need to do, right? We need to make the safe way the easy way, or make the easy way the safe way, however we want to describe that. Because there is the culture that we talked about, the compliance culture and capital piece. The culture is there, right? And it's just human nature, let's say, to try to get things done the easiest, fastest way possible, right? Everybody's trying to just get their job done and get it done effectively and quickly and easily. And that we need to make sure that that way is the safe way. So we need to be productivity focused and making sure that we're driving that into our entire design process. And a good piece of that comes into play with the way that we implement solutions in addition to where we implement them. So let's talk through conventional versus contemporary, because the generally speaking, when we're looking at product selection, we have some different choices, right? And there are many conventional solutions that we've used for a long time. And the question becomes, should we continue to use those solutions, or is there a better way? And there's, in many cases, what we would consider a better way, a better product solution. So first thing we talk about is electromechanical versus our solid state driven devices. So when we're thinking about this, that this can span both from the input side, the output side, and quite frankly, even in the middle on the logic. You know, the conventional methodology was based on electromechanical solutions. I mean, the primary one that we think about with this topic is the input device, right? When you look at a key interlock switch or a limit switch, where you're literally moving physical contacts in the body of a safety device. And as we all know, electromechanical devices, you know, will wear out because they are electromechanical. So, and the OSSD devices, on the other hand, these solid state devices, do not have that situation at play, right? So they are different. They work differently in how it all comes together. And incidentally, just a little bit more detail on the standards tie into this. So when we are looking, if you recall, on the devices, the solutions, the channels of each device, we needed a mean time to dangerous failure. So how do we get a mean time to a dangerous failure of an electromechanical device? That number is going to be highly dependent. Actually, it's going to be directly dependent on the usage of that device. How many times is that device used? And then we have to say, well, do we really know how many times that's going to be used? We have an expectation of how many times it typically should be used in an installation, but how many times is it used? And I would humbly submit that in most cases we don't track that these days. So on the other hand, when you look at a solid state device, the MTTFD, the mean time to dangerous failure, is not operation dependent. It is design dependent of the actual switch, and it is provided to you as a number by the manufacturer. So if nothing else, moving from electromechanical solutions to the solid state OSSD type solutions simplifies the implementation of today's safety standards. And we'll go through that a little more later, but wanted to talk about that a little bit now. When we talk about the conventional solution, many times we talk about very dedicated functionality, whereas contemporary solutions, many times we have many more things that we can do within a product than we had previously. And when we think about software configurable safety relays as maybe an example of that, or configurable hardware configurable relays, and other kind of aspects where we typically had a dedicated function. Now we can have multiple functions in one product that can handle different things. Device-specific relays, controllers, same idea here, where we can have configurable, programmable type products. Separate standard and safety systems. If we had a safety controller in the past, we generally would have separate safety controllers, separate standard controller. And there are situations where that is still required based on specification, desires, industry standard requirements. But generally speaking, for machinery, that is not required. And now we have this option for a fully integrated platform where everything is in one place, right? That's a more contemporary methodology. Same thing here, fixed I/O configurations versus expandable and distributed I/O with safety networks. Historically, very limited diagnostics. Now with contemporary solutions, we can get much more much more information, as Andy was discussing. The information is very important. There's safety in information, right? So the diagnostics is very important. And then looking into the output side, you know, typically, especially for motion here, but also with drives, right? With variable frequency drives, typically hardwired safety, and with contemporary methods that can all be embedded into the network. And so there are definitely many ways that we can take advantage of more contemporary technologies to simplify the implementation of our safety circuits and safety applications, but also provide more value to the overall system by doing so. So there's a lot of things at play here when we look at the more contemporary or modern, smart, whatever word we want to use, products that are available. So this is just one kind of quick overall view example that I'll play a short video here for you, and hope it works, because we were having some trouble with this before. And I don't hear any audio, so I will talk through it a little bit. Ultimately, when we look at smart solutions, we have lots of different devices all the way around the product's application space, right? All the way around a manufacturing line. There are many, many places that we have safety that we need to work through. And what would be really useful is to gather information about the operations of these devices, perhaps per shift or per hour or per whatever, right? Because what we can do with that information, that's a very simple piece of information. But what we can do with that information, if we have that available, is number one, if we choose to use old school technology, I don't recommend we do, but in this particular case, we have a older technology, conventional technology safety switch that has a limited life, right? How do we know how many times that thing has been actuated? Well, if we track it, we know, and we can track it. And when we do, we can do just what's described here. We can set up an alarm, say, hey, you need to go swap out this device. It's reached its age use that's acceptable, right? And again, that's just one example of where that information becomes useful. Another information use that I would say is, you know, we've had actual applications of this occurring where we track how many times a safety guard door interlock is opened, and we expect that it only is opened, you know, 2 times a shift, let's say, to change out, let's say, a reel of tape that's on a box taper, right? So suddenly that door becomes opened very, very frequently. And then we say, well, why is that? Why is that happening? And then we dig in and we find out that it's really because the tape keeps breaking. That's why that door is getting opened. Why is the tape breaking? Well, it just so happens that somebody made a change and now is using different tape that saved, you know, a couple dollars on a roll of tape. But guess what? The dollar saved on that tape was completely eaten up by the challenges that tape provided to the system. So the you know, just the information of that safety initiation, how many times, you know, can lead you to other cost savings and productivity gains that have nothing to do with safety. But it's all about gathering that information and understanding it to be able to make intelligent decisions. So when we look at an overall platform of the contemporary smart solutions that we offer, I just like to throw up just this big picture slide for a couple of minutes and just kind of walk through a few key elements on this roadmap, if you will. You know, we see this green line on top. This green line, it should be teal actually, but this green/teal line up here is Ethernet connectivity, right? That's Ethernet connections. So we have, in this case, our CIP safety based controller. This is the Compact Guard Logix 5380 platform. And that is running CIP safety communication down to all these devices in addition to standard control, right? So there's a CIP safety, well, I take that back. This one is not a CIP safety connection. Let's just say that it's Ethernet for now, and we'll make it cleaner. CIP safety connection to this PowerFlex 527 drive as an example. So you can send direct commands over Ethernet to this drive from a safety perspective. We don't have to hardwire a safe torque off terminal to an IO point. It's directly over Ethernet IP. We'll skip over this one. The armor block here, this is safety distributed I/O, which again, all on Ethernet IP, CIP safety. So safety connections here to standard devices, which then are transmitted through CIP safety over the network, or outputs you could fire here as well. Or, you know, the platforms that mix and match. So you have a point I/O platform here, which, you know, you can mix and match safety and standard I/O. So that makes it very, very useful as an I/O platform. And there's actually a Flex 5000 I/O platform that's not pictured here as well that does that same thing, where you can mix and match your safety and your standard I/O. And again, into the drive world, right, where you can do CIP safety directly to Kinetic's family of drives, to the 755 drive, depending on what card you put, option card you put into the drive, these drives. CIP safety encoder, CIP safety multifunction access box, and two products that are near future, say before end of year is what we're being told, which is Ethernet IP direct connection CIP safety scanner, Ethernet IP direct connection CIP safety light curtain. Now coming back over here, this product is actually not CIP connection, but it's an Ethernet connection for diagnostics. So we can utilize a separate safety control in various little applications that we can get the diagnostic information directly up into our main control system. So the safety is managed and maintained separately, but the connection to the Logix controller providing the information as to what's going on in that particular controller with safety, okay? And then the device layer underneath, where we can use different connectorization methods to a whole bunch of different safety product platforms that are useful for us to implement and solve applications. There's also on the overall right here, there's another product that we'll talk in a little more detail on as we go, which is called GuardLink. So GuardLink is effectively a linking technology that allows us to put these devices all in series and pull back information of the status of each one of these devices individually without any additional wiring. So that is very valuable for many applications. So that's just a very kind of quick, high-level mapping of many of the CIP safety solutions and many of the contemporary product solutions. There is not a product on here other than this e-stop and this contactor. Nothing else on here is electromechanical in nature whatsoever. Everything here is solid state. And that's one of the things that we keyed in on early in our discussion, is this old way versus new way, you know, conventional versus contemporary. These are the contemporary switches, devices that we want to focus on. So again, the smart contemporary safety solutions, when we look at the functional safety requirement for us to think through that entire function, we'd like to use smart contemporary safety solutions across the entire platform where we can. So that's our input devices, our logic devices, our output devices. So let's talk about input devices first. So input devices. And we talked about this a little bit in the beginning, where, you know, when we look at the contemporary versus the historical solutions, the conventionals are where we'd like to move away from where we can. So this electromechanical technology that has no diagnostics, no visual indication of what's happening at the switch, the probability of failure of that device is based on how often it's used, and it's easily defeatable in application, right? All I need is a spare key in my toolbox, on my key ring, in my pocket, etc., where we can easily, you know, defeat, bypass, whatever word you want to use, that switch. And we want to move toward this contemporary technology where we use solid state technology that has that self-monitoring diagnostic capability and intelligence built into the device. We get the indication of status on the device. We get the probability of failure to be independent of how often we use that switch, and the ability to make the application tamper resistant, right? And we do that through different coding methods. And we'll talk through that a little as we get into product specifics, but you can kind of see the picture here of what we want to move away from to what we want to move to. And again, as a reminder, just based on the implementation of the standards, and when you're going through the calculation to get to a performance level, using solid state technology devices greatly simplifies that effort. Okay, so more reliable performance, improved uptime, and improved mean time to repair with all the information. So real high level, we're not going into specific details on these products, but just for awareness and make sure that we understand what they are and why they're important. The contemporary safety inputs, a collection of those door interlock devices, is in front of you here. And these all use an advanced technology in safety, which is RFID, right? So we're using the RFID technology for the coding, and actually use inductive, we use coils for sensing that the actuators are in place, but the RFID technology is what we utilize to maintain that safety signature, if you want to call it that, for the switch. So we know that that actuator is in front of that switch. Now there are two ways in most of these products, and some there is only the uniquely coded option based on application space, but generally speaking, there are two ways that this can be implemented where every sensing actuator, if you will, is the same. So they all have the same RFID code. When that is used, it's essentially not really that much different, right, than what we talked about, where if you had an extra key in your toolbox or your key ring, now all you need is an extra actuator in your toolbox or on your key ring. But they can also be implemented in what we call uniquely coded. The standard actually calls high coding now. We actually released our product before the standard was completed. So we should probably go back and change that to high coding, but our literature, everything says uniquely coding. So high coding or uniquely coding basically says that that code is, there are more than, I believe, and it's been a little while since I've kind of looked at the standard to recall this number, but I believe it might be more than, maybe it's either 1,000 or 5,000 combinations, right? Just like your car key will go start somebody else's car, go find that car. It's pretty hard to find, right? So high coding says that whatever that number is, it's above this number of the combinations that are out there. So effectively, you have a uniquely coded pair, right? You have this actuator will only work with that switch. So you can't have that extra spare actuator to trip up signals. So those are available in your standard interlock device, which I'm going to use this, it's cool. Your standard interlock device here, as well as your locking devices, whether it's a bolt lock, which is the LZ here. There's also an MZ product that's very similar to this that's just about to come out, as well as what we'll call a TLS GD2. And note that this one does have a key. The key here to the key is that this RFID actuator is mounted separately from this key, because to reach the current safety standards to the highest level, you need to have key break detection. So this provides that key break detection. If this key is inside that switch and this actuator is not at the switch, we consider that broken key and fault the switch. And then of course your large body switch for full body access, that's basically, you know, integrated handle, request to enter, reset, whatever you can want to configure these buttons to be. This is also a new switch here, which is more of a process switch, which is electromagnetic. So you have an electromagnet that holds the door closed when powered. So all of these products, no dedicated controller. They're all very simple. They have OSSD outputs like a light curtain, excellent tolerance to misalignment, etc. You can wire them in series and maintain the highest levels of safety. And if you recall I think it was yesterday, where we talked about dry contact switches in series will not be able to get to the highest level of rating based on the requirements of the categories and the performance levels. Okay. So that's just a real quick snapshot of those type of input devices. Another very important contemporary input device to know about is this cable pull switch. We think about cable pull switches and we think about electromechanical contacts moving when we pull the cable. That's the old way. The contemporary solution is to utilize the Lifeline 5, which is actually a strain gauge. So when we pull on the cable, which would be obviously attached to this spring, we pull on that spring or on that cable which pulls the spring, we're actually measuring what the strain is on the strain gauge. So what that allows us to do is develop a fully solid state, higher high diagnostic capable product that provides us great information, provides us increased performance, because this thing is set up so that a light push against that cable, if you just happen to brush by it as you're walking by, it doesn't care. It only is going to trip when it sees the tension go outside of the applicable tension window, or when the speed of pull is beyond a certain speed that it is looking for to understand that someone is trying to pull that cable to stop the equipment, as opposed to something just leaning against the cable. Again, all the diagnostic information through LEDs, also an output that provides that same diagnostic information for tensioning, so that you can identify that the tension is in a state where it needs to be adjusted before it becomes a problem and before it shuts the machine down. Okay? Similar kind of concept here, where we look at old way, new way. This is the most contemporary light curtain solution. It actually has a transceiver stick instead of a transmitter stick and a receiver stick. The sticks are the same. They are a transceiver. They can be either a transmitter or a receiver. And the function of that light curtain is determined by the plug-in module that we plug into the bottom of that stick. Different solutions for a basic application versus an enhanced application. There's a basic version for on-off only. That's a very simple kind of product. And then there is an enhanced solution that provides the built-in laser alignment tool, the ability to do blanking, muting, etc. And this platform is really where we talked about on that first slide, that CIP safety light curtain that's on the horizon. This platform allows us to get to that point, and it allows it to be a very simple migration path from one solution to the next, because we can utilize the same stick and just use the plug-in module to change and update and upgrade our application. Okay. Couldn't be complete without mentioning the laser scanner as a contemporary solution option. In many cases, there are folks that are using safety mats that may benefit from using a different technology. Not to say that safety mats, there's anything wrong with safety mats. They are electromechanical. In some cases, they are a better solution based on dust, dirt, debris, etc. There are reasons why we still do need to use some of the more conventional methods. But in the case where it makes sense, the laser scanner gives a lot more flexibility, again, a lot more information, and the ability to do different things, where you can have warning zones as well as safety zones. Depending on the model, you can have multiple warning zones, where maybe as you encroach upon the first warning zone, there's an alarm that goes off that says, hey, you're getting too close. You intrude into the second warning zone. Maybe we institute a slow mode, start to slow the speed of the machine. And if you reach the safe zone, if you will, then that's where we actually, cut the machine, kill the machine, if you will, from a safety perspective. So there's many different things that this provides beyond the typical approach to guarding an area. You can use these vertically or horizontally, so you can use it as a diffuse light curtain, if you want to call it that. So there are many ways that this can provide a very, very useful tool for a more modern smart solution. And the e-stop. The e-stop is pretty darn conventional, no matter how you look at it. It's still a dry set of contacts. There are standards that require that at this point. The interesting thing here, though, is how can we take advantage of the setups and systems that we are pulling together from a system perspective? How do we make the e-stop easier to integrate into that? So this slide kind of highlights that we offer e-stops with the connectorization that is set up to match up with many of the products that we've previously talked about, so that we can use them together in a system very easily and allow us to gather that insight. And again, e-stop's the simplest of things in many ways, but which e-stop is pressed? Geez, if I had a lighted e-stop, I'd probably have a better shot at that, right? So these are lighted e-stops. And the last input device that I'll talk about is something just a little bit different, which is what we mentioned previously, the safety encoder. This product really allows us to do very different applications or applications that we previously would do. We can do them a very different way, a much simpler way in a lot of cases. So we can utilize this in conjunction with our safety controllers to do many of the same functions, if not all the same functions that we embed into our safety drives or that we have as standalone safety monitoring type relays, like MSR 57P for those who may be familiar with our product line there. Because this is a direct connection to CIP safety, and we have everything we would need, right? We have position, we can have speed based on how fast that position is changing, acceleration, etc. Right? So we can gather that information over the network and make decisions based on that and do various things in our applications. And it is as you see there, it's the first encoder out that is CIP safety over Ethernet IP, SIL3 PLE capable. So that's just a very quick overview of the input side of the equation, but an important one, because the input device is many times, I'd hazard to say overlooked, maybe is a good way to put it, as a key element of making sure that you have a solid performing system over time. Many times those electromechanical devices that are out there are problem areas. They are. Keys do break, and switches do wear out, and things that we don't necessarily manage as well as we would need to determine if that switch has reached the end of its useful life. So I would submit that, taking a hard look at those input devices, strongly considering where it makes sense to look at the more contemporary methodologies and solutions out there to better the safety performance of your circuit, just by implementing those types of solutions. And by the way, all these OSSD devices that we talked about, they have that dynamic self-checking, and they also have self-monitoring. So whereas historically, or the electromagnetic switch, let's say electromechanical switch, we need to, well, depending on your performance levels, et cetera. Generally speaking, these days, when we have 2-channel dry contact devices, we use pulse testing, because we'd like to identify if there are issues in the wiring, right? So we pulse test those. We send two different pulse test signals around the 2 different channels. And if we see that those pulse tests are not there, we know there's an issue with the wiring or with the switch, and therefore we fail to a safe state. However, we never know if that switch is going to actually work until we put the requirement on it, right? Because it is a dry set of contacts. We cannot determine whether that set of contacts is somehow damaged and in a fixed position that will not move, whether that's a welded contact, whether that's physically damaged switch. We can't tell. We will never be able to tell that. That is a fault we cannot detect. We eliminate that fault with the OSSD devices. So many good reasons why we need to look at these contemporary inputs. Now let's talk a little bit about how we're going to connect those together, because that's another challenge that is in the practical world, something that we need to be aware of and look at. So quickly through a few slides that talk about different, what I like to call Lego sets to simplify your life in terms of wiring these devices to an input. We have a relay in the cabinet there, could be any input. So first we have a standard T-port structure. These are just wires. There's nothing fancy in these taps. We basically just take these 8-pin OSSD devices where we have the access to the input to the OSSD and the output of the OSSD, and we basically just daisy chain those all the way through this looping plug or shorting plug here, which then brings back the signal and we're good. So very simple. No enunciation on the taps. If we use contemporary solid state devices, we get that enunciation visually at the device level. We also have a Lego set number 2, where you get additional enunciation capability. The devices are still all wired in series. If you're using contemporary solutions, you still get the diagnostic at the device level. You also get the diagnostic at the box level. So you have little LEDs here. And then you also pull individually each auxiliary contact from those devices back to a PLC input card for enunciation at the machine itself. So that's another Lego set. So we get more diagnostics. We're kind of centrally hub and spoke kind of located here, star topology, however you want to say it. But we get some additional diagnostics. But we still have to run a good number of wires to make that happen. So the next thing we'll talk about is the technology path that is phase one is complete, and we're continuing down the path for additional implementations. Phase one of this solution called GuardLink is through a safety relay, but GuardLink is basically a trunk and drop topology that uses standard 4-pin cables for the trunk and 5 or 8 depending on what device you have connected to. You can use whatever generic safety device you'd like that connects into these smart taps. You can have up to 32 smart taps per GuardLink, or per link, let's say. And you can have 30 meters in between devices. So if you do the quick math, you end up at about 1,000 meters in terms of length that you can have. That's a long way. But each one of these GuardLink GuardMaster dual GuardLink relays, the DG relay, has 2. So you can actually have 64 devices and 2,000 meters worth of length. And no matter what device you have connected to these smart taps, whether it be an e-stop, which is obviously a dry contact device, or if you don't heed my advice and you use standard dry contact devices, you could have standard dry contact door switches, etc., and still maintain that PLE SIL3 rating. The beauty of it comes in is that we have a Ethernet IP interface that will optically connect. There's an optical bus on the back that connects, and we connect that into our Logix controller, a standard Logix controller. This is a gray box, not a red box. So this is providing us diagnostic information, but not safety. Safety is managed by the relay, but the diagnostic information is provided as to which switch in that trunk of 32 or 64, which switch actually is opened, okay? And that's all handled through a very clean interface through an add-on profile into Logix. And not only do you get the information as to which switch is tripped, but you can also do remote resets, lock or unlock specific doors or all doors all over the network. Okay, so that's a very quick snapshot of GuardLink. Now, the next thing we'll talk about in terms of connectivity is on-machine safety I/O. And on-machine safety I/O, obviously, well, not I shouldn't say obviously, but on-machine safety I/O will only work when we have a GuardLogix processor. That is what it's tied into. It's a CIP Safety I/O, which needs a CIP Safety processor. But that connection scheme, highlighting connectivity, is also extremely simple. So we have the same kind of devices, all these contemporary solution devices that we offer have the connectivity set up so that it directly plugs in to these on-machine I/O devices. So regardless of which connectivity solution that you need for your application, it can be covered by a variety of methods into a variety of different controllers. So that's pretty important to at least cover to make sure we understand that the connectivity is simple and comes together nicely. So when we talk about the next piece, we talk about logic. 3 kind of main tiers of scalable solutions for logic in contemporary solutions. Number 1 is the GSR relay family. And this is very high level. If there's any questions on all these products as we go through, by the way, feel free to reach out and we can get into a much more in-depth discussion for your specific needs. This is a very high-level overview. But these particular relays, these GSR relays, are universal input type devices. Any standard inputs will go in there. 2 normally closed, OSSDs, 1 normally closed, etc., all those kind of things. And there are different versions. There's about 8 part numbers now, I believe, maybe 9 at most. But those 8 or 9 part numbers take the place of hundreds of part numbers prior in the safety catalogs that we used to print. So it's a very, very scalable solution that has a lot of different application depending on what your needs are. But where this comes into play from a smart solution is this optical link again. There's an optical bus on the back. There's an optical link into this Ethernet IP interface, which goes directly into Logix through an add-on profile, gives you, in the case of the standard GSR relays, gives you diagnostic information of every point on this relay, what its status is, what its connections are, etc. And with the DG relay, as we talked about with GuardLink, it gets you down to device level information, what's going on with those, and be able to remote reset, lock, unlock doors, etc. Okay, up to 6 of these relays per Ethernet interface. Kind of the next layer, if you will, of scalability is a software configurable safety relay. And this is a 22 Safety IO product right here. And this is managed with either, or programmed or configured, managed with either of 2 methods. One is connected components workbench, which is complementary software. The second is through a direct add-on profile to Logix. And when used in Logix, it actually will save that configuration within your ACD file. So it's in one place, very simple to manage the programming. And this bullet here, I neglected to mention previously, single wire safety. It also has single wire safety connectivity. Single wire safety is what allows us to make a modular relay system out of the GSR relay, in addition to being able to take one wire, one terminal off of this CR30, let's say, and go directly to either another CR30 through a SWS in connection or to a GSR relay, to expansion module, etc. Allows us a lot of flexibility. And then the third tier in our strategy is the GuardLogix controller, where we start to talk full integration, everything controlled in one platform, safety, discrete, motion, process, etc. And that is available either in a compact GuardLogix type solution or a ControlLogix type solution. And we'll talk a little more about that as we go forward. But where these things kind of fit, just really briefly, just general guidelines, hardware configuration, a few zones, a few circuits, and we've already talked about the benefits down here. But it's really more that simplified solution, where relays will do the job, but we need to get that, and we want to get that diagnostic information back and be able to better manage our application. That's a great fit. I mean, as I'm sure many of you out there on the phone have experience with many products that, sooner or later you run into a point where it's like, I can only buy so many of these before I should have bought something else, right? So at some point you start to get into an economic situation where it makes more sense to move into maybe a CR30 type product, as long as software configuration is acceptable. Sometimes hardware is preferred, and then a little bit of extra cost is worthwhile to maintain the hardware configuration. Generally, from what I see, it's between 3 to 4 of these relays. You start looking at possibly looking at a CR30. Again, software configurable as we discussed. So a few zones, few circuits, gives you some good capability for programming different ways and different zones, etc. Different logic. But when you start getting to more than 3 zones, or maybe even more than 4, I might push that up a little higher. But anywhere in that area where you start to get a lot more complicated, a lot more logic involved, a lot more tie-in to maybe some output devices that you need to have more advanced functionality on, that's where GuardLogix starts to make extreme sense. And again, single project, standard and safety, as we discussed. Again, this is a very high level, but we can get a lot of good detail, I think, in our discussion here. So when we look at logics in general, we have a slide that kind of builds out how this really plays in from a smart perspective of simplification. In addition to all the great information that we get out of it, just simplification is very valuable sometimes as well. So if we have a typical, like say, solution that has a few things going on, right? We have a separate safety system. We've got some different solutions to manage our I'd say conventional technology drives, let's say, where we have contactors and maybe some relays driving these. We can simplify. First thing we simplify is we may get rid of the switch. We might not need that because we have all of, never say never, never say always. But the vast majority of the product out there that we offer has 2 Ethernet connections for device level ring or linear. So many times we get rid of the switch. We may not necessarily need the type of control we had previously, managing the safety on the output devices, where we can embed that into the product. The separate safety system can be fully integrated into the controller as well. And then, of course, all the data and diagnostics that was associated with that can be pulled into the existing platform, existing network. And then simplification of other networks. We have DeviceNet here. It could be a competitive network that's tied in, where we simplify that, streamline it to one network, and drive all that simplification into the process. Okay. So one question that usually comes up, I want to cover pretty quickly here, is one question that usually come up is, well, how is this network thing work? How's that safe, right? So just very quickly, what makes SIP safety safe? There, we talked about the 3 C's of safety earlier, so these are the 3 D's of safety. So if we have a safety product, a safety system, a safety application, or in this case, a safety message on an Ethernet network, we need to look at these 3 Ds. So we need to consider duality, we need to consider diversity, and we need to consider diagnostics. And I think we verbally mentioned this the other day as well. So duality, we'd like to have no single fault be able to compromise our safety, right? So if we're doing something twice, then we at least have single fault tolerance. Diversity, if we don't want to have that those common cause failures, as we had talked about in the standards, right? So what we do in the case of specifically getting into the message here, we send the data twice. That's the duality. We send it once standard way and once inverted. That's the diversity. And then we also do checksums on each of those, and an overall checksum and a timestamp. So that's all the diagnostic information, right? So that's kind of what we're looking at. So that packet is what makes it safe. That's kind of how it works. It provides the duality, diagnostics, and diversity, which is interpreted at each device. So we have one piece left, which is the outputs. And when we talk about outputs, again, there's scalable options depending on what your requirements are. And this is a simplified view, and we'll talk a little more through some other pieces of this. But there's still a need to manage things that don't have integrated connections, as we haven't gotten everywhere on all product segments and all areas of technology, maybe pneumatics, et cetera. There's applications where we just need to still deal with the electromechanical solutions of a contactor. When that is the case, safety contactors are purpose-built to do that job. Highly recommend that those are used. If nothing else, the standards require mechanically linked or mirrored contacts. That's the critical, absolute critical piece. But we go a little beyond that, and we say, well, we want this to be tamper resistant. If these are supposed to be mechanically linked or mirrored, we don't want anybody to be able to take that auxiliary block off the front of the contactor, because then we can't guarantee that they're actually still linked. So there's those smaller things that make a big difference that are designed into these contactors. You do need 2 of these to have category 3. They're not safety because they have 2 contactors in one, if you will. They are individual devices that will need to be grouped together in groups of 2 to get the redundancy or the duality. And then, of course, we have both variable frequency drives and servos that have different functionality based on your needs. There are products that have hardwired safe torque off functionality. There are products that have network safe torque off functionality. There are also products that have advanced functions within the product itself, safe limited speed, safe limited position, direction, acceleration, stop, brake control, etc. And there are methods to do that kind of within the drive and only in the drive, but there are also methods to do that all over the network and leveraging logics and that safety encoder that we talked about earlier. And pretty much the variable frequency drive and the servo drives at this point from the Rockwell perspective have very similar functionality. In the 750 class, it's the S4 card. In the servo drives, it's the ERS4 is the latest, which is the CIP safety version that contains all the advanced functionality. And here, so just a little snapshot of an application space, if you will, tying it all together a little more with some diagrams of things. So this is a safe torque off with Ethernet IP, right, where we're driving it either to a 527 or a 5500, 5700. We can do that and get a safe torque off over Ethernet IP. If, however, we needed more advanced functionality, this solution would need to be changed, right? So, but there is some great benefit to simplification, again, looking at how that is pulled together. It's very, very simple as to how that is structured, right? So in this particular case, something a little more interesting, right? So now where we can take the drive itself and do safe torque off or safe stop one. We can do safe, as we had talked, safe position, safe limited speed, etc., all in the drive. In order to get there, this picture could be representative of either a SIL2 PLD version of that product, or there's also now a SIL3 PLE version. That's why it says that up on top. But ultimately, we'd need the additional encoder here to make sure we got to the SIL3 PLE for sure. But there are other ways to do that today, whereas that encoder doesn't have to be that standard hardwired encoder anymore. We can just use that CIP safety encoder and drive that solution that way. And there are methods to simplify the drive when using this encoder as well, depending on what your application is. So there's a lot of detail behind all this. This was a very high level overview just to give a sense of the products, and there's just a list of some of the output functions that we discussed. So tying this back in a little bit with safety tools for a second, as we had talked about, the Safety Automation Builder allows you to pull all these products into the bill of materials, get to Systema, etc. I would remind us of those safety function documents. There are safety functions that I know are being written right now all around this new safety encoder that we talked about. They should be out in another month or so, maybe hopefully earlier. But those safety function documents I would point us to for all of these types of solutions, whether it be the safety relay type solution, the CR30 type solution, or the Logix type solution. And last but not least, if we're in the world of Logix, that safety accelerator toolkit is a very valuable tool as well. So with that, we have some kind of closing thoughts, if you will, some final thoughts. I was joking with Andy earlier about Jerry Springer. I think that's what he used to say, some of my final thoughts. But really, if I was to take away from these 3 days, the 3 most important pieces of all the very important things we talked about, humbly, I would say that, driving that risk assessment as a very meaningful, solid, regimented, methodical platform and doing that well and following that life cycle is going to be critical to make sure that we're implementing things correctly to the risk, right? And answering that question, as we had mentioned at a couple of points in the conversation, how safe is safe enough? Is this safe enough? that's the way to do it, is to follow that life cycle, and the risk assessment is the first step. The other thing that I would key in on is the standards and the specifications, right? Making sure that we're doing the right things based on the current standards and methodologies, and then tying that right to what we talked about today with how do I make that easier, and how do I make my solutions more robust long-term and provide the type of functionality and information and performance that I'm looking for in today's technology, in today's world and beyond, is really looking at the contemporary methods. And again, even it's something as simple as a door switch can go a long way to making sure that we have a very safe, highly productive piece of equipment with the diagnostics, et cetera, that can be extremely useful. So I think the actual last slide, which you've probably been looking at in my background the whole time, is ultimately how we can help. We are eager to help. We like to help. That's kind of what we do, and where we can help, as you see on this slide, you know, from the very beginning of that life cycle all the way through with the risk assessment and safety lifecycle services. We didn't talk about lockout tagout systems and services, but that is a key element to this safety picture that cannot be ignored. And the structure and the methodology and the offering that we have around that is just it stands alone. It's unsurpassed. And of course, the world-leading safety products and solutions that we've talked about today. So Andy, anything to add? I just kept kind of rolling there. Anything to add that I might have missed on?
It's hard to pick anything up. You're a pro at this, and I do want to thank you so much for really all the slides that you put together, the information that you supplied to us. It's been a pleasure running this webinar with you, and really having you as my lead person here.
Happy to do it. It was awesome. Great to do it together. So with that, then I think we're good to go on the call. We actually, surprisingly, quite frankly, we've done pretty well on time every day. So I'm pretty pleased with that myself. So, but yeah, appreciate everybody's participation and attendance. And by all means, you know, we'd love to do one-on-one follow-ups with anybody on the phone that has any specific applications, specific questions, specific areas that you want to dig deeper on. We're happy to do it. And we will be following up with a copy of the materials for you, as well as links to many of the tools and other specific areas that we had links provided in the presentations.
And I do believe you'll be receiving an email asking for you to fill out a quick report card, per se, of what you thought about the webinar. Those are very important that we get those back. So if you please take, you know, a few minutes and complete those and get those back to us, I'd really appreciate that. And thank you so much for giving us time for the last 3 days out of your, I'm sure, busy schedules to join us. And hopefully we'll see you in the future for other webinars to give you more information, make you smarter. And with that, we'll say good day.